Hi, thank you everyone, and also thank you Macau University to give me the honor to present to all of you. I would like to use this opportunity to share with you my so-called, innovation journeys. But the most important thing I want your takeaway for this meeting is that to learn the methodology for innovation, because all of you is going to, take our future going forward. So we need a lot of you to think about how to use technology to innovate, to create impact. So the future is in your hands. So please use some of my past learnings to see whether it can help you to apply, the methodology to innovate for billions. And so in this case, billions is not just billions of dollars, it's for billions of people. So let's look at what I did in the past. So I think I'm pretty old now. One of the things that I keep telling my kids is that the reason I'm so driven is that I feel people's life is very short. So even these days, people are getting older and older. There is a statistic saying that a lot of people, a third of us is going to live past 100 years old. However, that's still very short. So what I'm hoping is that before I die, I can look back in my life and feel good that, hey, I did something. I did something for humanity. So that's kind of what is driving my day-to-day. And so if I look back my past, I did quite a bit of stuff. I won't say all of them are, awesome, but a couple of things that I feel super proud of is that everything I did in the past had impact billions of people. So let's look at some of the examples. I am the pioneer of using GPS and GIS technology for navigation. So today, every one of your cell phones or cars that are doing navigation I am the first one doing it. And a lot of the chip inside actually have my algorithm inside. So if you ever get lost using GPS, you can blame me, and I will accept that responsibility. But I can tell you, you will never, because I test so much, and I have full confidence that almost every corner case is being covered. Then the second big achievement I had done is that today's internet email is based on IMAP protocol, Internet Mapping API, and I am the pioneer of using IMAP protocol. I will tell you in what will happen in the good old days if you're not using IMAP protocol, but I will share that experience with you later. So that, I guess, impact almost more than 56% of the population worldwide. As long as you have internet, you will using internet mail. Then the third thing that I'm very proud of as well is that today, every bank, every stock exchange, the information system behind those data is done by me. So this is something that actually is quite crucial because for bank transactions or stock exchange, the amount of information is going through and also the speed the information is going through is super fast. But one thing is super important is that there cannot be data lost because every bit of data loss might imply that your bank account goes from $1 billion to $1, and that's not something you want it to happen. So that's the third thing that I feel very proud of. And then I have to say, 70% of the world's internet traffic goes through one of the products I make because I was behind Cisco's enterprise networking and also IoT network. So a lot of devices are transmitting data, and the data is being carried around the world, and that went through one of my products. And the example goes on is that I am the first one using SDN, software-defined network for Google. So, and as you know, about a third of the world's network is actually Google-related. So that is all going through my SDN technology. And so then I have a few more examples I'm not going to go into. But currently, one of the big things I'm driving is that I'm using RISC-V to create a new type of CPU architecture. I don't know the impact yet. Hopefully, that will also impact billions. So in a way that for my past 30 plus years of technology innovation, I think I counted because of this meeting. I counted I had invented and also productized about 26 products for my past careers. And all of them are very successful and also impact billions. Of course, not all 26 is impacting billions, but I think at least more than half did. So that seems to be pretty cool. I think for any engineers, if they can participate in one product that impact billions, that would be cool. But I did many. So a lot of people ask me, what is the methodology? How we can, replicate your model? And this is what I want to share with you. So first of all, I want to define the term innovation because I know a lot of technologists. They have a lot of so-called patents. I know one guy, he has 3,000 patents. Think about it, 3,000 patents, that's insane. But one question I asked him is that whether your patent is being used, he doesn't know. He's just doing innovation for the heck of it. After that, I actually lose all respect for him. I actually give him a hard time and say, you're just trying to make money by filing patents. That's just not right. I think the most important thing for innovation, you just need to remember two words. One is that whether this innovation is a practical idea. Can this patent be used? This is very important because if it's just for the innovation for the sake of it, then I can have thousands of patents too. But I don't have many patents. I only have 15, 20 patents. But every one of these patents means something. And so when you are doing innovation, you have to remember that. Am I inventing for something useful? So this is number one thing is very important. Then the second thing is very important is, does this innovation create value for people or for business or for humanity if you want to broaden it to a higher level? And so if those two is satisfied, then I think that qualifies as a good innovation. And so in this diagram, I think that it kind of provide a very good closed loop on what a good innovation is. So it has to have a business model. It has to solve a problem. Of course, it has to be creative. So when you think about innovation, these are the key things to keep in mind. Then after, my years of doing new things, I kind of try to summarize on the element of valuable or successful innovation. I think a lot of this is nothing new to you. Being a student or a technologist in the world, you probably already apply these type of technology to your day-to-day innovation. But I would like to summarize it in a way that, hopefully it's going to help you. For me, a successful innovation or valuable innovation have to contain 5 dimensions. First of all is that why? What kind of problem you try to solve for this innovation? Second, and also is the most important thing, is that how big is the impact when you address this problem? Then it comes to the how. And I think being an engineer, we are a lot of time just keep thinking about how. Reverse your thinking. Think about why first and what impact, then figuring out how. Because one thing is cool being a technology guy is that you know there is many ways to solve a problem. So having a how is not as important to know what and why. Then another 2 dimension I also keep as part of my innovation requirement is that is this good for humanity? Is it good for our people? Because I could be inventing a quantum bomb or something like that. Well, a button will wipe out, the whole planet. It is a cool innovation, and it is creating big impact because I will destroy Earth, but it's not going to be very good for our people. So in this case, it's not a very good innovation. And then the 5th dimension is also very important, is that how easy is for this innovation to be adopted. So for example, if our innovation is a particle bombardment gun or something like that, that takes a whole Macau to build. In this case, it's a great innovation, but it's not very easy to be adopted by everyone. So those are the 5 dimensions that I think good or valuable innovation I use as a guideline to help me to decide whether it's something I really want to pursue. So it's some experience I want to share with you. That's how I go about innovation. So now, going forward, in the next 10, 15 minutes, I want to use some of my examples on how to do innovation in the past. And hopefully you can use that as, a way to do what you are doing going forward. So as I mentioned to you before, I had done a lot of innovations, and some of them are quite successful and impactful. So I will walk you through my journey on how I do those and what kind of challenges I have to overcome, and then how I apply my so-called 5 elements of valuable innovation. So my first startup is actually doing applying the GPS technology for navigation. So why I'm doing it, I guess the reason that I was doing it is I'm actually trying to solve my own problem, because I'm very famous of getting lost. Every day I get lost. I think I just have too much in my mind. So even I'm going back home, every day I get lost. I don't know why. I think I'm just not paying attention. So when I just find out, that's about 1991 or something like that. A lot of you might not be even born, but that's when the US government launched the first batch of GPS satellites. There were 4 on the sky at that time. And so I read about that technology, and then I have this aha moment. I was like, whoa, this is something that's going to change our world, because if we use this technology for navigation, then none of us will ever get lost again. So I get super excited, went to talk to my boss. At that time, he was the founder for Trimble Navigation. That's the first company building the satellite communication chip. So I told my boss and said, man, we got to do this, because this is a tool no human can live without. And my boss was looking at me and say, hey, dude, you're crazy. First of all is that this is a $150 billion investment by the US government. The US government can say, I'm not going to do it. So in this case, there will be no such program. That's one problem. Second of all, it's going to take 10 years for all the satellites to be deployed on the sky to create a 24/7 coverage that we enjoy today. Third is that it's a really hard problem because at that time, there is no standard for any of the geographic information system. But his joke was that, hey, you can go do it. If you are able to do this, all of us will love you. Then I quit the company the next day and started my own company. So lecture number 1 is that you should do a business model, but I did not because I am a very passionate guy, because I believe this is something that's going to create big impact. I just do it without going through very detailed business analysis. But to start the business for this case is not that hard because it's just myself. I just need to buy a computer and a bunch of compilers and off and go. However, during this process, when I do the detailed analysis, I know it's a very daunting problem because at that time, first of all, is that there is no standards for all the geographic information system. So geographic information system means it's the digital maps behind, navigation. At that time, there were 300 different type of databases in different formats, and all of them are not very accurate, and there is no standard. As you know right now today, when you enter an address, like this is Macau University, you want to go back to Macau, mainland, I don't know, pick a restaurant or something like that. And for GPS and for we to do navigation, we have to, behind the scene, pull up all the geographic information systems to convert the data into the same format that the GPS position is based on. Because GPS position is based on the Earth is curved. All the geographic information system is based on the Earth is flat. So you have to do the real-time conversion right away before you can do the navigation. Then the second thing you have to do is you pull up all these databases and do very rapid calculations. Before going to point A and point B, there is some of the road is one way, the other road you have to turn, all that you have to do to calculate on the real time. So what I learned is that I have to convert these 300 databases into some standard that I can manage. Then another thing I find is that actually GPS position is not very accurate because the GPS satellite do not give you a position information. They just give you a time package. And that package just tell you, I am satellite number 1, I am sending you the data at T1. And you with the device is receiving that T1 signal from satellite 1. And your clock on the device need to be super accurate because all you mark is another time, which is T2. And so between T1 and T2, you know how fast or how far the distance is from the satellite. Then based on this information, you need to get 4 satellites simultaneously to calculate the 3-dimensional data we got on the Earth, which is the latitude, longitude, and altitude. Then after that, you do your navigation and all that. So I was like, holy cow, that's very complicated. So my first, excitement get tempered a little bit. So I spent many months to do all these data conversion and many months to figure out how to make the GPS signal as accurate as possible because GPS signal get interference by everything. The weather, all these buildings, and then the mountains, and then the glasses building, which create double paths, and et cetera, et cetera. So it took me about 6 months to come up with the first prototype. At that time, I only sleep 22 hours a day and spend 22 hours a day working on my code. And then every night I have to go out to test my product because there was only 1 hour of GPS coverage per day. So after 6 months, I've got my first prototype working. I spent about 2 years to make it perfect. And then after that, basically a lot of GPS receiver companies license my IP, and that becomes what's running on all your or cell phones or whatever navigation devices. So I guess my point on this innovation example is trying to let you know is that a lot of time to, when you truly believe in something, just go do it. But then the challenges is that there will be a lot of obstacles. Just don't give up. Break down the problem into tiny pieces and then solve it one at a time because you will get to it. Then after my GPS thing, since a company is licensing my IP, and also because I get the algorithm right, I never need to change it again. So I start looking for my next adventure. And at that time, run into a lot of problems. That's near year 98 or 99, before the internet boom, the dot-com days. At that time, what I find is that every time I switch computer or cell phone, I lost all my data. And the data includes all my emails, and then, the attachment comes with the emails and etc. And that's really annoying, because even at that time, nobody used email that much, but still, it is very annoying to move between devices. So what I find out is that most of those email or communication mechanism those days is based on a legacy protocol called POP3. POP3, the idea is that every time your device connects to the server, email server, it downloads all the emails to your device. So whenever you lose your device, and then after the download, it deletes everything on the server. Because in the old days, the network speed is very slow. So when you're trying to access the data all the time on the cloud, nowadays it's called cloud, it becomes very inefficient. So I find out there is a new protocol, a new standard called IMAP, Internet Mapping API or something, Message API. So I said, wouldn't it be cool that we switch to this API? Because then in this case, all the server is going to contain all my information, and I can move from devices to device very easily. So that's when I start my new company. And in this case, in about a couple months, we were able to come up with a new client based on the IMAP protocol. And then, quickly that becomes the standard. So Microsoft, Netscape, and a bunch of others start switching to this new protocol. And then our technology get acquired and it went IPO or whatever. So this is another good example of when you do innovation, think about what are the problems that people face day to day, and then figure out what is the good methodology to solve it. In this case, it's not even a lot of new innovation. It's basically using an open source protocol, and then we are able to make such a big impact. Then another third example that I also did was after my IMAP company did quite well, I decided to change field because I find that every time that when I look for a new area, I want to go into a brand new field. And I want to go into a brand new field that I have no idea of, because I find when you're working for a company, if you are doing something that is new, you will feel very uncomfortable. And I like that uncomfortable feeling because that drives you to learn and become the expert of that field. And also at the same time, you have this out-of-box thinking. Because let's do an example. If you've been doing, telecommunication for a long, long time, you become so good in this field. Everybody asks you, you know exactly, oh, this is a TCP/IP protocol. I have 6 layers of security, blah, 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 blah. And there is nothing new for you anymore because this is just something you do day to day. However, if I ask you to become a train controller, you will think, hey, I know nothing about this. However, your knowledge and know-how for networking can apply to control trains. You say, hey, you don't have fail redundancy. It's actually the same network problem, but you apply it to a different type of devices. So your out-of-box thinking actually can help the train controllers to really do things differently. So when I switched jobs, I want to do something completely different. So I went to join a startup, which is working it's the only company that does heterogeneous file system and storage management for all the servers in the world. So that sounds really weird. It's like, okay, I have to muck around the most underlying infrastructure for information. Is how you store the information, how you manage the information, and also make sure this information is highly available, never get lost. So I am a software engineer because I reset myself. Instead of running a company, I just become a software engineer. I work on a code every day. And after about a week working on this job, I was like, man, this is the most boring job in the face of the planet. Because we are on the top 10 layers of the whole stack. In order for me to test my code, I have to first install the operating system. Second is to set up the server. Then to create all the file system, whatever, configure everything. Then finally get to my code. And I have to repeat that about 30 times a day. Every time it takes a few hours. So it's just really boring. And so then after a week, I asked myself, can I make my own life easier? I mean, why do I have to jump through 15 vendors of stuff? Can I create a framework that which integrate these vendors' technology without they even know? Because asking these vendors to work with you, they say, who the hell are you? They won't work with me. But what if I just do it without they have to do anything? Wouldn't that be cool? So because of that idea, I basically every night, because at that time I already have my kid. So my kid goes to sleep at 10. So I go back to the office at 10 and work till 4 a.m. in the morning to prototype my idea. After 4 days, it seemed to work. Then I went and talked to my boss and say, hey man, look at this thing, it's so cool. And he was like, what the hell is it? I said, I don't know, but it solved my own life problem. So I showed him how it worked. He was like, whoa, this is cool. Let's go find Dell. So we went and find Michael Dell, and you guys probably all know him. He's the technologist behind Dell Computer. And so we went and showed Dell. Dell said, okay. And so he tell us to go away. And my boss said, we got the deal. I was like, Dell did not say yes. He said, I can read it. So I got my first award of innovation. My boss gave me a Burger King big, it's not called a Big Mac, whatever, the big burger, which costs $2. So we celebrate on a deal that he think we got. But sure enough, the next day, Dell gave us the deal. And then our stock double, we become all very rich. I don't know why, but anyway. So this is something that only take me 4 days to prototype, 4 nights to be exact. And then after that, the company dumped hundreds of people to work with me. But I still think my prototype is better than all these hundreds of people working on it. Because a lot of time, innovation is not about dumping a lot of people on it. It's about doing it right. But anyway, Dell every year threatened to throw us out because they think they have better idea. But I think right now it's 30 years now. They're still using my framework. So that's another example of innovation have to be useful and solve some problems. And the problem doesn't have to be very grand. If you solve the right problem, then it will have high value. And then another example is around IoT. As you know, I was the Cisco's CTO and VP overseeing Internet of Everything. At that time, Cisco is very proud being the #1 network provider in the world. I think they still are. And so we are looking for new opportunities. And with IoT, really happening, we believe that, the world is going to be all connected. So in this case, we define the thing is called Internet of Everything. So when I was taking up that job, one thing I noticed is that we Cisco have a problem. Our problem is that we think one clothes is going to fit everyone. So Cisco is leveraging the enterprise network to apply for everything. Now you think about it. IoT actually has a wide range of usage. For example, a lot of us has an IoT device already in us, which is our mobile phone. If you go into a car, there are 30 IoT systems in your car. Some of them monitoring your your car tire pressure. Some of them monitoring, whether there is some car adjacent to you. Some of them is helping you to do auto parking. All these are IoT systems. If we are using Cisco's approach, we have to put 50 internet enterprise switch in your car to connect everything together. That's just crazy. So I told Cisco, hey man, we have to go build the right type of products for the right verticals. And this is something that Cisco never heard of. They were like, oh man, that's crazy. We will not do that. And also, given that we are a big company, we believe every innovation is going to take 200 people and $100 million to do it in 2 years. This is our 222. Every proposal, you just need to satisfy that. I was like, seriously? Do we really need to take that much money? So I did something Cisco never heard of. I asked for $200,000 in 2 months. I was trying to come up with 2 people, but I only have myself at that time. So 1 person. And then within 2 months, I was able to build a vertical switch, basically leveraging what Cisco already have. And you apply it for IoT vertical. When that product comes out, Cisco was like, what the hell? And then my first deal is $20 million. So I did fulfill the 222. And for this $200,000 investment, we were able to generate more than $300 million of income for the next 2 years. And that's, actually I didn't even do much coding. So after that, I think Cisco understands that in order to do IoT well, we have to put a lot into consideration. First of all is that IoT has a lot of different type of protocols, 80 different type of protocols. And IoT environment is very different, whether you use it for indoor, outdoor, and also this industrial environment, the communication device needs to be different. And also the whole market need to be looked at is that our current system, in order for us to scale, we have to come up with things that are very power efficient. We have to come up with the sensors that can last forever, because if you ask people to change battery every 3 months, nobody is going to do IoT. So all this is something that created huge amounts of innovation opportunity, and that drives, hundreds of billions of dollars of new business for Cisco. And also it creates, so much innovation for everyone in the industry and in the field. And also at that time, that's when I start driving a new concept for IoT, is edge computing. At that time, we come up with a cool name. It's called fog computing, because cloud computing is really high up. Nobody knows where the cloud is. But if you want to do local computing, you can see and feel, so we call it fog computing. So we are the first to come up with that concept. But right now, it's being named edge computing, so it's the same thing. Now, this is what I am doing today, which is doing WIS5. So one might ask why you're doing WIS5. So if we kind of look back the journey of computing, what is the key component for computer? That is CPU, Central Processing Unit. CPU is equivalent to the brain in a human being. If computer without a brain, then it's not a computer. It's just, a dumb device that you, human, need to do things for that device. So for the past 40 years, there is a lot of so-called CPU architecture. So in the old days, we are using CPU architecture from Intel, IBM, and nowadays, we're basically using 2 CPU architecture for almost everything. So for the high-end computing or whatever server running in the cloud, usually they use an architecture called x86 by Intel. In our mobile phone, pads, gaming, and control unit, most of the time the architecture is being used is called ARM. These are the two architecture almost for 90+% of the devices in the world. The problem for these two architectures is that they are all pretty old. Intel is over 40 years, and ARM is over 20 years, and it gets overly complicated over time. Another problem is that these companies, they go from open to closed. So in this case, you cannot do much customization unless you pay huge amounts of money. Now comes a problem with today's trade war, and also countries being, instead of open, being closed. With China running into a problem. China has 0 CPU architecture of our own. So last year, if you heard about Huawei, all of a sudden say they can't make cell phone anymore. And a year ago, some other companies complaining. The reason for Huawei is that they used to license the ARM CPU architecture for their cell phones. Now, if ARM no longer renew their license, Huawei cannot build cell phone anymore based on the ARM architecture. Another problem for Huawei is that they don't have their own operating system for their cell phones. They license Android from Google, and that Google was ordered not to give Android license to to Huawei. So in this case, their cell phone is getting hit by no chip, no OS. And then in addition, US government also ordered that TSMC cannot deliver high-end chip for Huawei. So that's the third thing happening. So when I was back to China, I was like, hey, why can't we have our own CPU architecture? Or why can anyone has our own CPU architecture? And so this is when I bring RISC-V architecture back to China. So about 3 years ago, we used some investment to acquire the RISC-V IP and set up a chip company in China, focusing on doing CPU architectures. And then the second thing I'm doing also is that given this is a brand new architecture, you have to prove to people that it works. So then I created a AIoT SoC company to use this architecture to build chips. So the one that I just gave to Professor Martin is our first chip that we taped out last year. I'm taping out a new one just now. After that, also, in order for us to solve the whole chip problem, we need to also have an operating system. So I create another company to do that. So for the past 2 years, I was very busy. But in a way, it's good to report back. First of all, is that as far as RISC-V based CPU architecture, we are 1-to-1 compatible to ARM now. Whatever ARM has, we have. And end of last year, we surpassed ARM by delivering the first open source architecture, which is the fastest RISC-V CPU architecture in the world, which is all done in China for China. So we no longer need to worry about US government say you can't use my IP. And then in addition, as I mentioned, I created a company which applies this technology to practical use. So we created a new company called Leap5. This company does 3 things. One is to making sure that we create a series of SoCs leveraging the low-end to high-end RISC-V CPU architecture. So my chip is range from 40 nanometer to 28 to 12 nanometer technology, depending on the vertical you go after. And each chip contains a security infrastructure to make sure the chip is unique. So you no longer need to worry about the chip getting hacked, or the data coming from the chip might be fake. Then another thing we also do is that I add blockchain to all these chips, so data coming out from the chip cannot be tampered with. And I also created something called the ABC platform to help you to follow the value of your data. So you will know who's using your data, how many times they've been using your data. So in this case, in the world of digital economy, you know the part of value you contribute. So this is what we had done. And then in addition, to avoid having the same problem that Huawei run into, that we don't have our own operating system, I also created operating system optimized for WIS5. So we have optimized Linux for WIS5, a compiler IDE, and all the performance toolchain and BSP needed to make the application run on the WIS5 architecture. I open sourced the effort so then everybody can use this to build their own applications. So this is the cool chip that we are taping out right now. Is a 12 nanometer technology with 4 CPU cores running in there. Each core can run the speed of up to 2 gigahertz in clock speed, and also include AI acceleration and GPU in the chip. And it's a generalized gateway, so you can apply it into almost all the IoT verticals. And one of the things I will, early in the talk I mentioned to you is this thing practical? So before I define the chip, I already find the user for the chip. So I work closely with China's State Grid. This is going to be the SoC system going to be used for China's State Grid, all their edge AI monitoring environment, and also the smart gateway is going to be based on this chip. So we are running the pilot for over a year now. So when my chip is being taped out and come back, we can switch to the official product. So this is some of the examples. I'm not going to go into all the detailed vertical use cases, but you can check out my website to learn more if you're interested. So now I kind of share my past experience on how to do usable or valuable innovation. Hope you can use those examples to reflect what you're going to do going forward and how to, make all our innovations valuable. Now you might want to ask, it's like, hey, you already, or all your innovators already did so much. What can I do? Is there anything left for me to do? The answer is yes, a lot of it. So let me share with you some of the crazy things that I think you should think about and you should do, because the future is really in your hands. So let's look at, this is too fancy. I didn't know I have animations. Let me go back. Hey, how do I go back? Today, I think we live in a very rapidly changing world. And in this world, there is a lot of big changes impact us day to day. For example, all the social networking tools. Everybody is on Facebook. Everybody is on game. And then things like AI. Everybody talk about, in the next 10, 20 years, AI is going to automate all our jobs away. There is a statistic saying 50% of the jobs will be replaced by AI by 2050. Now, what are we going to do? Because half of you will have no jobs in 20 years. Then at the same time, with globalization or deglobalization, we created, or we see a lot of challenges of certain technology cannot be used here, certain technology cannot be used there. And then in addition, a lot of people are talking about, forget about this physical world. Let's all move to a virtual world. We all go live and work and play in metaverse. Now, what is that got to do with, our beautiful campus? Do we need it anymore? So all these, I think, is interesting challenges. But the way I look at it is that it also creates huge amounts of innovation opportunities for all of us. One thing that I personally really care and passionate about is that global warming. As you know, Earth is our only home. However, the challenges is that for the past 200 years, ever since industrialization, we've been damaging Earth in a speed that is unheard of in the history of Earth. In a way, it's quite scary if we look at the statistics. With the temperature of the Earth increased by 1.5 degrees since industrialization, a lot of people is going to have no more food because there is no more land to farm food. And if the temperature keep increasing by another 0.5 degrees, it actually doesn't even need that much more. We'll reach 2 degrees warmer for the Earth easily. With that temperature, I think all the coral reef in the ocean will be dead. In that case, it's going to impact every species in the ocean, and that in turn is going to impact our food source. In addition, with this type of temperature, a lot of the ocean is going to be rising by a lot. With the rise of ocean, lots of people's home is going to be underwater. And that alone, probably 90% of the farmland is no longer to be farmable. So all this is going to create huge amounts of impact for us, 20, 30 years coming. And for a lot of us, that's going to, I'm getting old, but a lot of you will be in your middle age and you're going to have kids. They are going to live in this really crazy changing world with extreme weather and also, extreme temperature range. So I think that, this is a call for all of you to think about. With all these big impacts, that create huge opportunity for innovation. So just think about all the challenges I mentioned. Every challenge means every innovation opportunity. So now think, with AI going to display 50% of our jobs, that's today's job. But we can at the same time create tomorrow's job. If the AI is going to do, the for reaping or the manufacturing the job, now all of us can do creative jobs. What is it? What kind of tool we can help people to boost creativity? This is something you can think about. Another thing is that, as I mentioned, with all the farmable lands are gone, why do we have to farm? Can we do vertical farming in these buildings? We don't have to use soil, and we can use very little water to farm. So in this case, that's a lot of chance of innovation. Another thing for teacher, 校长, is that from all the statistics, with all these mobile devices, the kids' attention span are really decreasing. From last I read, kids' attention span is already teeny. Now it jumped from 12 seconds down to 8 seconds. So how can you teach the kid in a way that get their attention is something that we can think about. And with all the global warming and also people getting more and more, we need a lot of energy, but we need a lot of clean energy. Right now, in the world, 70% or maybe more, the energy generation is still by coal. In this case, nuclear energy seems to be really cool. Fusion energy seems to be really cool. But everybody deemed this is super unsafe. So can you think about what to do with clean energy that does not generate carbon? Things can go on and on, can we do gene editing to make death become a disease? Nobody should die. And can we, get rid of all plastics in the way that we destroy Earth? Can we save the Earth? So the list goes on. And all this become innovation opportunities for all of you. So in summary, I would like to ask you all become the problem solver. And to solve the problem right, just remember, the 5 elements for innovation. And another couple of things I really want to encourage you. Every problem, there is a lot of hard problem. There is no easy problem because all the easy problem already solved. The truth is. So every problem seems to be hard, but don't get discouraged because the truth is that for every hard problem, actually you can break it down to teeny little problems. And the important thing is solve teeny little problem a step at a time. Eventually you can solve the hard problem. So don't just say, oh, this problem is too hard, I can't do it. You can, just break it down. And the third thing is very important is think out of the box. Don't allow people to box you. Don't just say, all the people do it this way, I will do that way. No, just think out of the box. Just come up with something crazy. There is nothing is too crazy. So just think. But then the important thing is to try because you can't just think about it. You have to try. So that's something is very important. And also another thing I really encourage people is think big and don't follow what everybody is doing. Like right now, everybody is mining Bitcoin. Everybody is talking about NFT. It's like, are they valuable? I don't think so. They probably make you $1 today, but if Earth is gone, who cares, right? So I think that, set a high goal for yourself, make your life count, and also have a sense of urgency because we might not have tomorrow. So let's live hard, pray hard, and work hard. Anyway, Earth is in your hands, so please help us and create a better future for all of us. Thank you.
Thank you, Dr. Kong, for her sharing, and please stay. Now is the Q&A session. If you have any question, you may raise up your hand and our staff will pass the mic to you. Let's welcome Professor Jerome Yan, Head of Centers for Innovations and Entrepreneurship, to come onto the stage to be the host of the Q&A session.
First of all, I would like to say thank you to Dr. Kong for such wonderful sharing. But I also would like to just ask you one little question. Where did Dr. Gong receive her high school diploma? I know several students sitting over there, Dr. Gong's so-called junior little brothers or whatever, in which high school? Is Beijing Middle School. So today for the Q&A, I will let some of the University of Macau student or faculty members to ask questions, but I would also like to save 2 questions for Beijing students to ask. How about let's start from who would like to kick off the first question? Anyone? Yeah.
Hi, Dr. Kong. I'm from UM. Thank you for a very inspiring talk. I think more than all your innovations, I'm very impressed with your energy and enthusiasm. Let me start. I have actually 2 questions, but I'll start with a more negative one. Okay. Were there some ideas that you had dismissed that now is big, that you wish you had taken up? I was thinking, for example, blockchain, and now looking back on those missed opportunities, what do you think now?
I think that for me is in generally when I look at innovation, I look at how useful it is. I think about how valuable from business sense down the road. So in a way that for missed opportunities, I actually find, for me, it's like a lot of time what I find is that, for example, I have a big missed opportunity in Macau because about 8 years ago, I want to help Macau getting smarter. So I come up with a proposal and actually Macau government don't even need to pay. But the solution is going to really help Macau and also the travelers to Macau become much easier. But that never panned out because the government did not really support it. So this is one thing I think is too bad for Macau people, but I still want to do it. Another thing that I feel that a missed opportunity is actually nuclear energy. Because I feel that if you really believe E equals mc squared, nuclear energy is actually the most powerful, efficient energy source for us. But because of one or two mishaps for nuclear energy, people kind of treated nuclear energy like, super bad, and still continue using coal-based energy. So currently, I'm really hoping, from the country level, we really look into nuclear energy, but this time, don't look at uranium-based energy, but using rhodium instead, because it's a much better nuclear form of energy. So I have lots of ideas, so the example can go on and on. But as far as Bitcoin or blockchain, I actually don't feel it's a missed opportunity. Because for me, blockchain is a good technology for making sure the data is not tampered with. But right now, I think people just use it in the wrong place. Not sure I answer your question because I can go on forever on that one. Yeah.
Okay. How about Professor Xu? Dean Xu?
Okay, so Dr. John, and so wonderful talk.
Thank you.
I enjoyed it so much, and your talk really reminds me of research motto we used. So think big, aim high, but we start with small. Mm-hmm. Yeah, so we think of serving a billion people, and in the meantime, we want to make the billions of money. Yeah, so that's your title. And so your example, your experience give us perfect cases, and start with some thinking of the big, but start with the small. Mm-hmm. Then gradually, and you will make up your own the fortune.
Yep.
Yeah, so that's the perfect example. So I just, and especially, so the last few slides you mentioned some even bigger things. So I just want to echo your vision and your experience, so your vision, basically. So, okay, so I do not have the specific questions, and so I just want to make a few comments about that.
Thank you.
Thank you. Thank you so much.
Thank you, Professor.
So any other question? I'd like to, how about a student from Beijing Middle School? Do you have any question to ask your super alumni?
Okay. So good morning. I'm a Form 5 student from Beijing Middle School, and first of all, I would like to thank you for giving such an impressive and inspiring lecture. But and you've also mentioned the issue of global warming, which is I really appreciate that. But my question is that, when people are innovating or conducting scientific research, we might inevitably create, make things that contributes to global warming. For example, when we're doing different experiments, there might be some undegradable substances, chemicals, or for example, when people are launching spacecrafts, there might also be more greenhouse gases emissions, which might create bad impacts to our environment. But this is the only way that we can do to pursue human advances in technology. So what do you think we can do to find a balance between innovating, pursuing advances in technology at the same time while we can protect our environment?
Great question. I actually personally think that all space exploration should not destroy their home planet. So if you look at today's space exploration, it doesn't use any carbon generating fuel. So this is something that at least is not adding to the problem. However, I do echo some of your comments is that a lot of scientific research, when it's not well thought through, it will destroy our environment before it realizes it. So for example, why we're using fuel in the first place is a good example. If at that time we already realized it's going to generate so much green gas for Earth, we probably can choose a different energy source, but we did not. So I think that this is something I don't think we have a perfect answer, but I think it's really require a lot of so-called education and rallying cry, like you mentioned, because I think with global warming, now it's impacting so many sectors of our human life. I think a lot of the scientists already start realizing it. And also for all you younger generations, whenever you do innovation, you need to consciously put the impact in mind. So I think this is something I don't think we have a answer, but I think it's just something that people need to think about. For example, right now, Elon Musk is putting in a lot of satellites on the sky. I actually constantly pinging Elon Musk was like, hey man, you are going to jail Earth. Because think about it, if he's putting a couple 100,000 satellites on the sky, China is going to do that, India is going to do that. We have no escape. Because if we need to send shuttles to outer space, we might hit one of these satellites. Then we blow up in the middle of the sky. So things like this, we have to constantly think about and challenge the people that come up with these innovations. So I think this is a great question, and we really need you guys to think about new innovation, the type of impact to the environment and the humanity. So thank you.
Thank you.
Any question? Any more question? Yes. Yeah.
Hello, thank you. I wanted to ask you about the digital split that is happening, especially between, the Western world and particularly the United States and China. I mean, we are in a particularly interesting place because we are in mainland China, but, we can access most Western social media here, whereas 500 meters up north we can't. And obviously, Huawei and other big Chinese technological giants are already blocked in in the United States. So how dangerous is this for something that was created, the internet, was created to unite the world? Thank you.
Yep. I think that this is going to warrant a really long discussion, but let me try to simplify it in a way that I look at the digital divide. I think digital divide, to me, I break it into two pieces. One is the technology aspect of it. For technology, if you don't get to access the latest technology, for example, you are in the middle of the Africa, you don't have network, you don't have cell phone, you can't access anything. In this case, you are behind the digital world because you don't even get to see anything. So related to the technology thing, I think I can help, because this is why that we are using WIS5 to create, because it's cost effective and you can specialize in a lot of stuff. Building your own customized chip, and it's affordable. So in this case, we can at least reduce the digital divide from the technology aspects of things. As far as communication, I think the world is getting to be very scary, because I don't know about elsewhere. My home is in US. for the past 5-10 years, I observe how the social networking is polarized the whole country. So 50% of the population thinking, COVID-19 is fake, is somebody making it up. 50% know better, but like 50%. And also there is now in US, people believe that Earth is actually not round. Earth is flat, and God created Earth 6,000 years ago. And everything we see, which shows that things are before 6,000 years, they say it's fake. It's God making it to, fool people. And then, 50% of people are technology savvy. So I think that for these type of polarization and in the communication, due to communication, what I would recommend is that, first of all, is I can change what the government is doing. But I think for all of our individual, I will ask you is that don't believe everything you see on the internet. Just poll different sources. We all know how to read. Don't read, Facebook posts and saying, oh, XYZ just did XX, and then you believe it. Do a search. Google search, Baidu. There is all sorts of capability for allow you to do a little bit of investigation. Poll different sources and go to some trustworthy source to study. And this type of behavior is good for two things. One is to help you form your so-called fair opinion. Two is that during this search, you're learning new things anyway. This is something that I recommend all of us to do, because I can't just go tell the communist country or the US government, say, hey man, you guys need to share real information. It's not going to happen. But I think for all of us, if we do not become the so-called sheep or so-called people that can be programmed, now, after a while, these people or these social media cannot manipulate us anymore. So that will be what I recommend.
Well, now I would like to give you a little hint. Dr. Gong just received an honorary doctor from our university. Today she come here to share with us such wonderful talk. Then I think many of you would like to know, how about in the future, what Dr. Gong would like to work with us? Let me give you one little hint. Dr. Gong just received $400 million US grant, and then she will set up a company in Hengqin, and then there will be lots of opportunities. So I would like to let the student ask, maybe you can raise the question, how can I participate in a project that Dr. Gong is going to start later, okay? Does any student would like to ask any question about in such area?
Yeah, we are hiring. Yeah. Who wants to join us?
Okay. Any question from the floor? Okay. Yeah. Any question? Okay. Over there.
What specific areas are you looking into, and what kind of expertise do you need?
So the company we just set up in Hengqin is called WiseWave. You can look it up. And is going to produce the fastest DPU chip in the face of the world. It's called DPU, Data Processing Unit. So we are looking for chip designers, software engineer, hardware engineer, anything, because currently we only have 3 people, so we need more than 400 plus experts to join us. And I think this is a very exciting company. It contains the fastest shortest IP in the world. We want to use this IP to integrate with different type of chip architectures to create something called chiplet based CPU architecture. If you guys look it up in Google, it's CHIPLET. This is a new chip design approach. It's very fast and also allow, chip providers to kind of hold on to their so-called black box. And using our company will provide a die-level SerDes integration. And we also partner with a bunch of semiconductor packaging companies. Using the advanced package technology, we'll be able to create a really fast chip, very fast. So yeah, please let me know whether you will be interested. The company is just literally right across from Macau University. If there is a door, you just walk over. So we by design is trying to recruit some of our top talents. If you are not yet graduated, you can see whether you can be interns. Other than this company, we also have a few WIS5-based companies. As I mentioned, we do WIS5 CPU IPs. So there is a company also looking for lots of people. And then another company we're doing is we design SoCs based on WIS5 and also systems based on the SoCs. So we have opportunities from front-end, back-end chip designs to, OS level, firmware, software development to application and system design. The nice thing is that sky is the limit as far as semiconductors. So there will be tons of opportunity in this big Bay Area because the Chinese government understand in order for us to really solve the semiconductor problem, we have to invest. So this is where, a lot of opportunities is to open to all of you. So please participate. Thank you. You can contact me, by the way, if you're interested. You can add my WeChat or whatever. Ask Jerome, he has my contacts.
And sorry, I would like to give you also one more little hint for the company that set up by Dr. Gong, also working together with the PBOC in electronic payment over ECNY. So that is the area, I think, in fintech. So I think I would encourage students, if you are interested in such area, please do contact me, or I can pass your contact to Dr. Gong, because such area use the RISC-V chip to set up the e-payment system will be a big project from Dr. Gong's company.
Yeah, so since I got the mic, I will talk more. So that there is also a lot of research fundings being set aside to encourage innovation. So if you are interested, we can create joint research projects together and go after the funding support from Zhuhai or Guangdong or Macau University, actually. So one of the things I can help is I can provide a base development platforms from the chip level or the software or hardware system level to you, and then you come up with the necessary AI algorithm or necessary component to create your own innovation. The nice thing about this is that we already invest and upfront, so I spent probably $50-60 million in the past 2 years to come up with the chip already and to come up with the platform. So the risk is no longer around. Now it's just a matter of taking it and create, something that you feel passionate about. So I'd love to work together with you on that as well.
So, thank you, Dr. Gong. And because time, we are a little bit overrun, so we have to stop the Q&A session now. Okay, thank you again.
Thank
Dr.
you.
Gong. Yeah.
And thank you so much for your opportunity.